Hello and welcome back to module number 3. I hope everyone is well and everyone is safe and the hurricane did not damage or hurt you and your family, and you're ready to continue our exploration of advanced statistics and analytics using R. So far in module 1 and 2, my focus was on descriptive statistics. The idea that descriptive statistics allowed us to analyze one variable at a time. Now we are going to move from one variable to two variables, and we are trying to do that by examining the relationship between those two variables and how one can predict the other. And for example, blood pressure can predict your life expectation. Or the SAT score can predict your college performance, or eating vegetable can fit the health of a person. My answer is yes, eat more vegetables, but this is the type of analysis that we are going to cover that in bivariate analysis or bivariate relationship, and that is the aim of this chapter or module. So in order to make my life easy, I'm going to use a lot of visual. I'm going to use, in this case, scatter plot, which illustrate the relationship between two variables. So the idea here is that it will help me to display two variables. Again, I am middle-aged person. I am very concerned about my age and the fat I have in my body. So age in two variable. So what is the relationship between age and fitness? That's something that I'm always obsessed with. So the idea here is that as we get older, we are gaining more fat and we are not active as we used to be. So the idea here is that in this type of analysis, in bivariate analysis, we are looking very closely, is there a close relationship or a straightforward relationship in the sense of is it linear or not linear. So one of the things that is usually often measured, and we often hear about that, is advertising a sell. If you advertising, they promise us we will sell more stuff. So the idea here is again to illustrate the idea is the relationship between two variables. Advertising, the amount of money you spend on promoting your brand, and the end result in your selling your merchandise. So the scatter plot is easy to identify this type of relationship. We have positive relationship, we have negative relationship, but we can also have no relationship at all. So the idea here is the line upward or downward, or the curve with no patterns or patterns at all. So how strong is the pattern? Strong or weak? So this is the scale. When we are talking about visualize the data, this is the things that we are often need to be concerned when we present this type of relationship in our boss or our family or our professor. And so the idea here is, again, positive relationship can be, in this study, can be measured the number of hours spent of studying and the final grade in the course. So the more you study, probably the better you do in your final course. Negative relationship is the age of the car and how reliable is the car. And again, if you have an old car, you need probably be more careful about that. No relationship, this is the thing that we will find out using the scatter plot in order for us to do that. Next, again, we are talking about two variable. We are talking about correlation coefficient. And correlation coefficient comes in many forms. It helps to determine the relationship among points or value in terms of they change either or together or separately. Generally, the correlation coefficient of a sample is devoted by a small r, and correlation coefficient of the population is devoted by p or capital R. So, in other words, a sample is referred to the observation of the items drawn from the population. In contrast, the entire population, whether you examine each item from the entire population. So, sample correlation coefficient, small r, and the idea here is that we are ranging the score, is it -1 to 1, which is where -1 indicate strong negative correlation and 1 indicates strong positive. 0 indicate a very weak or no linear correlation. So in the interpretation, again, the layout, this is what we will find. Another issue is, again, the issue of indirect and direct. The perfect correlation of -1 or 1. Again, in other words, so you will have better sense when you conduct that type of analysis what the result indicates. The formula for the correlation coefficient consists of the following notation. We have x and y, and again, the two variables that we are trying to measure, and this is what we are trying to measure, where the end result is the r, small r, in order for us to do that. An example of 6 children were selected, data about the age and the weight in kilogram was recorded and showed the following table. So we have age and we have weight, and this is the table that we have. In order for us to apply the formula that the correlation, it will show us the following. It will show us the age, which is in years, the weight, which is in the y. We multiply the x and y. We multiply the x square and the y square in order for us to get the full essence of the table, in order for us to apply the formula and again follow the direction in order for us to get the score of 0.759. Okay, so this indicates there is a strong direct correlation between age and weight. And again, I'm a white guy, I'm obsessed with weight, so again, this is a red line for me. So another example, relationship between anxiety and test scores. And again, this is something that we've been studying again and again by researchers and educators, and this is example just to give you more sense about correlation coefficient, about that and how we measure. In this case, is the R is equal -0.94, which means it is indicates strong correlation, but again, this is how we measure that. The next type of correlation coefficient is person sample correlation, and it is measured the strength of any linear relationship between two numerical values. Linear, again, is a straight line, and the idea is that we draw the best fit through the data points of two variables. And again, the same score, the same indication of -1 is perfect negative linear relationship, and compared to +1 is a perfect positive relationship. The value of 0 indicates no relationship between them. The formula of that is really similar, but in this case, we in this formula, the x and y goes together, and we usually apply that and multiply that into it. So example, this is example of how to do that. I thought it would be a good indicator for you how to pursue the correlation coefficient in this case, and how we apply that. And I'm using the example in our textbook from page 82, and where the visitor for special collection and visitor to all archive rooms, and we have the total, we have the mean, we have all the indication for us to fulfill the requirement of the formula in order for us to do that. So again, the issue is that we need to calculate the standard deviation score. Will take 1 minus 4 equal minus 3, and the second score is 3 minus 4 indicate equal to minus 1. So this is the value of R in Pearson's R evaluation. So this is where we conduct differences between the two formulas, and in this case, this is a way for us to visualize in order for us to see what is the best fit in order for us to understand it. How do we do that in R? And I'm sure that we are already, some of you already did that, but in this case, the function called core is the function that we will use. We need to define what is x, what is the container that hold the value of x, and what is the value that hold in the container of y, and we will do core test in order for us to do that. He will give us the person product movement correlation data, and he will define df equal 3 and the p-value also. And in this case, if it is a sample, and I will go over the sample procedure in R in the end of the lecture, but alternative hypothesis is true correlation is not equal to 0.95, and the interval is what it is consist of. Those are the things that I need you to start thinking about when you are trying to analyze or to understand that. The next coefficient analysis is the Sherman ranking coefficient. And the idea here is that it is named after Charles Sherman, and it's often devoted by the Greek letter rho, which is the pi. In this case, is non-pragmatic measurement of the statistical dependence of the two variables. And it is under this formula we are going to, again, the value that we are looking at is +1 or -1, and again we are using that as a capital R. Rank is usually what we are looking for. So the formula is a little bit more complex, which is, again, I don't want you to be panic about what does it stand for, what does it include. So in this case, we have the N, we have the D, and everything in between them. And what you're going to see that, you're going to understand that the data needs to indicate those values. So in Sherman ranking correlation coefficient, we have ordinal data that is already rank form, and we have interval or ratio data that is converted to ranking. So the objective here is that we need to apply the ranking as a way to do that. Direct example from our textbook, public library, user participate in competitive event that organized by the town council. There are two events. The first one is bicycle race, and the second one was cooking a dish based on a local farmer's market. And the library selected 5 users, which is a sample that is often read about bicycle and cooking from their collection. The table that I'm going to present here is what it is consists of. So we have 5 people: James, Greg, Ruth, Lisa, and David. And there are cooking books that they read, the bicycle books they have. We have the 1 and the 2, and those are the numbers that we do that. So the sum of the square of the difference is the d square. In this case, 4 plus 1 plus 1 plus 1, it is equal 8. And the n, the sample size is n, and the sample, n square is 25. And those, so this is the way we are going to implement that to do that. So in R, I simplified the process. I did the analysis. It will come up with S and a p-value, and the alternative is no rho is not equal to 1. The estimate, a sample estimate is 0.6. So what we learned so far, we learned about the idea of 2 variable, analysis of 2 variable. It's not going to be hard, but again, I want you to have that we cover here 3 type of analysis. Each one fit in different categories, where the last one, we have the idea of the properties, or the idea of the square with the sum of the square of differences between those 2. So those are the main differences. We will employ the R example to code to run the R. So now let's go to the R part of the module. And in this case, we are going to go over basic module 1 and module 2, and we learn about how to create a container that holds the object in R. In this case, A holds the object of 1, and we can manipulate that or add to it. We talked about good names and bad names. We talked about the functions and what is the idea of a function in R and what does it apply to. And the function in this case, again, as we talked about the last time in module number 2, is the idea that we can multiply or apply a function in order for us to sort the data. And the idea here is that we are talking about a sample. So a sample, we have 2 functions or 2 structure in a sample that is usually talked to. We have defined it with a replacement or without a replacement. I gave you a more direct example in the end of this. The idea of a sample is that the idea that with a replacement or without a replacement, and I want to make sure that you understand that. So when we say replacement as true, is the idea that we will apply the replacement. Without a replacement, it will be false. So in this case, if a unit occurs more times in the sample, then the sample is drawn from replacement, and that's the idea of a sample with true or false. And you will see example of that in the exercise or throughout the module that we will cover. So I want to go back to where we start and what we talked about the last time. And with replacement or without a replacement, true is a replacement is in place, and without a replacement it's false. And so you need to be aware of it, just to show that it is part of our terminology that we need to do that. A more concise definition and replacement. It is here, what is the idea of a replacement or with replacement, and I hope it makes more sense. The function as a constructor is the R function is a first class object, which means that they are treated much like any other R object. So the functions can be passed as an argument to other functions. So I can take the function, for example, mean, and apply it to a different part of my argument, or when I write my own function, and I can use the function that already exists. I don't need to invent the wheel every time. So every function in R has three basic parts: a name, a body, and a set of arguments. To make your own arguments, you need to replicate those parts and store it in R. So the syntax of in R with regard to function, it has to have a name which that holds an argument. The formal arguments are the argument indicate in the function definition, and not every function call in R use all formal arguments. So again, you need to be aware and just to be sensitive to it with that regard. The next subject I need to cover, and again, the issue of two variable, is the idea of normal distribution. We talked about the idea that when we visualize two variables, we usually expect to have a straight line. And so the idea of normal distribution is the idea that the two variables actually has some distribution that can be bell-shaped, and means that the standard deviation of the data set and probably the distribution of the curve is of 1. So this is where we are trying to again understand what it is. In R, the distribution functions has a very defined definitions that you can use to measure to see if your data set has normal distribution. R norm is generate random number from normal distribution. D norm is probability density function, and again it will allow us to calculate the x and the mean, the variable, the mean and the standard deviation. P norm is the cumulate distribution function, and Q norm is the quartile function inverse to what the P norm consists of. So, example of a code with normal distribution. If a distribution has two indicators, two variables, the mean and the standard deviation, they are the location and the spread of the distribution. For example, the length of any textbook may be normal distribution with a mean of 100 and standard deviation of 16. The length of a textbook produced before 2008. And so the normal distribution is 280 and the standard deviation is 10. So again, the family of norms can be standardized with two normal with the mean of 0 and variance in 1, and in order for us to do that, we can apply the formula of z equal x minus the mean divided by s. And in this case, how do we do that in R? R norm, we have a set of data 1 to 10, again 1 to 10, and we have the 16. And if we will run the R, it will come up and tell us what is the R norm will be equal to 94.17. And before 2008, again, because the number was a little bit higher, it was not 100 pages, it was 280 pages, the R norm will be a little bit higher. If we would like to illustrate how to visualize it, we will use the function called hist, which is the histogram. We will say that define the x is, we have the x, the probability is true, the color is gray, and we will say the main is the normal mu equal 1 and the sigma is equal the mu is equal 0 and the sigma is equal 1 in order for us to come up with the following histogram. So this is the idea behind it. Another way for us to look at data in R is the idea of a vector, which is a sequence of data elements on the same basic type. So the members of a vector are usually called components. Nevertheless, they are also called numbers in this site or in this class. So here is the vector containing three values, 2, 3, and 5. And if we will add here to a vector, we will be able to add the issue of log of values, which is true or false. And again, the issue of a string, and as I defined the string last time, is the issue of ability to pull it to other dimensions, for example, as a text or as a word. And by doing that, I will be able to add more dimension to my analysis. The using of logical vector as an index is also part of what we need to be aware, and when we are when we're using it, the position of the logic vector is true is returned. So it has to be true in order for us to do that, in order for us to measure the distribution in that case. So using character vector as an index, again, this type of indexing is usually when dealing with a name vector. And again, this is what we will come up with names and how it will display. We can modify the vector, and this is how we do that. And our textbook talk about that quite often. I hope you will have the book. It is a good foundation to the R programming, or deleting the vector. We can also delete the vector by simply assigning a null to it. And we can also talk about metrics. A matrix, again, in the context of this module, is two-dimensional data structure in R, and it consists basically the idea that every matrix similar to a vector, but additional contains the dimensional attributes. So in this case, 2, 4, and 3, 1, 5, and 7. Again, we can define the matrix. We will say A is equal to matrix, and I will have the R start allowing me to add the dimension, and we allow to the number of rows, the number of columns, and fill matrix by row, and in order for me to display that. So this is the idea of a matrix. Or we can also ask the R to list it as an object. Again, this is the idea of a listing, and we can slice the list by the square bracket, and we will use it quite often when we will start using a little bit more advanced sequence in order for us to do that. But again, I want you to become familiar with the terminology that what is the functions, and slicing is part of a function that R provides us to do. Integer is the idea that we are using a whole number. To declare integer variable in R, we are usually call it as integer. For example, x as integer minus 3, and as a result, R will keep it as an integer and will identify itself as an integer. Again, this is the example. String, another way for us to sort the data as a text rather than number, and it composed of a character, for example, hello, and this is a word and not a number or value. And again, this is where the string comes into play, and we can edit and add dimension to it. Character represent a single element, such as a letter of the alphabet. And again, this is something that we can do. Declare by R that is a character. An example, x as a character of 0.14. And I can say my first name and my last name, and I'm going to paste it in order for me to display that. Factor is another way for us to manipulate the data. So in R, the factor takes a limited number of different values, such as variables that are often referred to categorical variable. In our textbook, we define categorical variable, which represent type of data that may be defined as the color of the hair or the color of your eyes, and it can be hair black, white, bold, a gray, for example. And in this case, the factor is going to be displayed here and going to be contained in order for us to apply to it. Logical is the use of logical variable, either true or false. So in R, the logical value makes a comparison between the variable and provide additional functionality, and we can add to it, adding or subtracting to it, for example, x and y, and we can ask, is x bigger than y? I showed you how to import data from Excel and how to improvise it. You can do it in writing, or you can use the RStudio for it. Again, sample, just to make sure that I repeat myself and or are clear about that. A sample, this is the syntax in R that in order for us to do that. So we have the x and the size of the sample. Replacement, we can be true or false with a replacement or without a replacement. Probability, usually right now we will say no, but in the future we will see what is true if the probability. And with the arguments that you're going to compose your sample syntax in R is the x, the n, the size, the replacement, and the probability. That's it. So in order for us to do that, this is what we will come. That's all. In your assignment, you're going to have a simple assignment that you're going to have a data set and you're going to manipulate that using what we cover in class. I hope it was successful. This module was successful, and I made sure that I cover not only the R, but also this statistical element of two variables. Until next time, enjoy, and please do not hesitate to ask. Until next time, bye. Whew.